Now, let's look at the next example I'm going to show you over here. I have 9 and I'm raising it to the power of 3 over 2 now. Now, what should I do over here? Now, all this while, the earlier example that I gave you, that's going to be 9 power of 1 over 2. We already understand what does fractional indexes mean, right? We already established a rule over here. The denominator of the fraction will tell you what root is that. So in this case, that's going to be the square root, right? But we keep only focusing on the denominator. What about the numerator over here? Like in this case, 3. What does that mean over here? Now, to understand what does this mean, I'm gonna split this fraction into numerator and denominator. And then we resolve the equation one by one. So I can factorize this, right? I can factorize this like so. So I will have 9. I will separate the denominator first. So what I will get is 1 over 2, all right? And I'll put a bracket over here. And then I will separate out the numerator, so I will have 3 over here, right? Okay, so what I have did is I have factorized it out. Now let's take a look over here, this question over here. This is gonna equal to this, right? Based on this rule. 1 over 2 multiplied by 3, I should get back 3 over 2, right? Now, let's solve this one by one, okay? Let's solve what's inside the bracket. We already understand what does this mean. All right, we already understand what does this mean. So 9 power of half tells me that's the square root of 9. Okay? And then outside here, I have a cube, so I'm going to write down cube over here. Okay, we can continue to solve this. Square root of 9 will give me 3, and I have my cube outside here, so I'm going to have cube. 3 cubes will give me 27. All right, so that's how we solve it. So basically, what does this mean over here? It's a two-step. First, the denominator. We already understand what is this. All right, it is the root. And the numerator will tell you how much it is raising up to the power. Okay? So based on this, we can actually write down another rule over here. So it's going to be very similar to this. So if I have a, and I raise it to the power of m over n here. So that's going to tell me is the n root, okay, n root of a, and this whole thing, I'm going to raise it to the power of m. Okay, so that's the rule over here. Okay, so that is what this means, right? Now, why did I not mention this in all the earlier example? Like, for example, I can use back the same example. Right? Instead, I'll use this. Let's just use 8, power of 1 over 3. Okay, let's just use this example. So based on this rule over here, we know that this is the cube root of 8. And I raise this to the power of 1, correct or not? And we have already understand what this power of 1 means. We have written our rule over here. Any number with power of 1, we will get the same number. So that's why in this rule, we didn't emphasize about the numerator, because it's going to be the same thing. But in this case, if the numerator is a different number, it's going to be different now. Okay? So that's basically what it means. So let's try out this, okay? We have already solved this. This is 27. Now what about this one? Okay? Now this one, same thing over here. I have 125, all right? Our cube root, all right, over 3. This tells me I have to cube root 125, and then I will raise all of these to the power of 4. You see, what have I done? I have just applied the rule over here. And then if I want to solve this, the cube root of 125, that will give me 5. 5 raised to the power of 4, that will give me 625. Okay? Now, take a look at this again, same example. I'm going to do something different over here, like in this example over here. Like, if you notice when I factorize this out, I factorize the denominator first and I put the numerator inside. Well, actually, can I do the other way around? Like, can I factorize out, I put the numerator inside and the denominator outside. And let's try out with this question over here, okay? Now, if I were to do it in this question over here, so instead of like cube root first, I will raise 125 to the power of 4 first, okay? And then, only then, I will raise this to the power of 1 over 3. Okay, this basically means cube root, right? So what do I get over here? So 125, if you raise it to the power of 4, you actually get a very huge number, which is this one. And then what I will do now, I will cube root this whole thing here, all right? This whole thing here, cube root, and surprise, surprise, you should get back the same answer over here. Now, why is this? Why is this the same thing? Okay, I can prove to you this by showing you a simple example of multiplication. 3 times 2 times 1, that will give me 6, right? But what happens if I change the order? So if I have 2 times 3 times 1, what do I get? I should get 6 as well, right? If I have 1 times 2 times 3, that should give me 6 as well, right? So basically what am I showing here? When we are multiplying numbers, it doesn't matter how we arrange the number, you will get the same answer over here. So in other words, for this question over here, I can also write like this. For this A, I can raise this A to the power of m first, all right? And then this whole thing, I will root it, I will n root it. Now over here, these two things basically means the same. Okay? But what do I prefer over here will be this one. I will prefer this method over here. Why? You can see the difference over here. If you were to take it to a power over here, you will usually get a very big number. I do not like my numbers to be big because it's very prone to error. So instead, I would like to make my number nice and small, and then I will only raise it to the power of any number that is stated in the question. Okay? So let's continue with all these other questions over here. So again, 16. I raise it to the power of 3 over 4. So what do I get over here? So instead, I'm just going to apply the rule over here. So in this case, I'm going to take the 4th root of 16. And this whole thing right now, I will raise it to the power of 3. Okay, the denominator will tell me what root is it. The numerator will tell me how much do I have to raise the power to. So solve this in your calculator. The 4th root of 16, I believe that's going to give me 2. All right, and I raise it to the power of 3. 2 to the power of 3. And that should give me 8. Okay? Now what about this question over here? Again, I have a negative over here. All right? So what should I do? All right, what should I do? Same thing. In mathematics, we dislike negative. So if you have the opportunity to eliminate negative, do so. All right? So in this case, what can we do? We can apply the first rule over here. So what do I get over here? That will be 1 over 4, and I raise it to the power of 5 over 2. And then we can just do the same thing as what we have did so far. So what I will get is 1 over the square root of 4, and this whole number here, I will raise it to the power of 5. And what do I get over here? I will get 1 over 2 to the power of 5. 2 to the power of 5 will give me 1 over 32. Okay? Same example, all right? So again, negative, I will change it into a fraction first. All right, the next thing I will do is I will have the fraction, the denominator, I will square root it. And this whole thing over here, I will raise to the power of 3. So what do I get in the end? I'm gonna get 1 over 7 power of 3. So 7 power of 3, that will give me 1 over 343. Last example. Okay, again, I see a negative, so I want to change to a fraction. And again, for the denominator, I can rewrite this into the 7 root the 7 root of 2187, and this whole thing here, I'm going to raise it to the power of 5. Okay, we can solve this in our calculator, and what do we get? The 7 root will give me 3, and I will need to raise it to the power of 5, and that will give me 1 over 243. Okay? So as a quick summary here, when you are dealing with fractions, fractional indexes where the numerator is no longer 1, it can be 2 or any other numbers, all you need to do is to look at the denominator first. That will tell you what root is that. But do not forget, after you have solved that, you have to raise that to the power of any number that is shown in the fraction here. Okay?